Hello all, let's start part 2 of section 6.3. In part 2 of this section, we are trying to find the data value from z-score. I'll put as a subtopic here for you, finding data value from z-score. First, I will create here a formula for you. I'll do kind of proof, or I can say I will derive the formula for you. You are not required to learn how you get this formula, only just memorize the formula. Actually, this formula comes out from the z-score formula. Look, our z-score formula is z equals x minus mu over sigma. X represents what? Data value. Our X is what? Data value. If I want to find the data value, if I want to find the value of X, then I have to solve this formula for X. To do so, the first step, I will multiply both sides of my equation with sigma. You see, sigma cancels out, and I'll end up with z times sigma equals x minus mu. Now, again, I want to solve for x. Here, I will add mu to both sides of my equation, correct? These two cancels out, you see, x is now alone in one side. Then I can say x equals z times sigma plus mu. This will be the formula, the box one. You don't need to learn these steps, correct? You don't need to. You are not required to learn any proof or any deriving any formula. This last formula, which is x equals z times sigma plus mu, this is the formula that you can find the data value. If the z-score is given to you, also the standard deviation in a problem given to you. Before going to an example, let me write the steps. How do you deal with the problem step by step? The step is a little bit different than the previous lecture. In previous lecture, our first step was to find the z-score. Here, your first step is draw the picture. Picture comes as a step number 1. Step number 2, find z. Find z-score. And step number 3, definitely you are solving for x. Step number 3, solve for x. It means use this formula. Correct? Now I'll do an example for you, and you see how easy it is to deal with these examples. It's the same example of the weight. Example. The weight is the mean. It's the example of the weight that I did in previous lecture, correct? But this time I'll try to find the data value, correct? Again, your mean is 172 pounds. It's given to you. A standard deviation given as a 29 pound. Your standard deviation is 29 pound. But here in this example, they're asking something else. What weight what weight separates the lightest the lightest 99.5% from the heaviest heaviest 0.5%. 0.5%. Correct? What I do here in my step number 1, I'll draw the picture. Please always draw the picture. If you don't draw the picture, then it's so difficult to understand what you are dealing with. The graph of normal distribution, correct? This is my 0, but actually, remember in previous lectures I told you, if you draw a line here, this side will be 50%, and this side becomes also 50%. This middle line divides your graph to 50%. Of course, if this is 0, this side is the highest or upper, correct? In this example, this is the heaviest. This side is heaviest, correct? And this side will be your lightest, correct? Always draw, because students get confused. Okay, the problem says lightest of 99.5%. When you come here, that will be 60%, 70%, 80%, 99.5% is actually here, correct? You are increasing the lightest. It means you are shading this side, correct? This is the heaviest, correct? This area is 0.995. They are asking you to find first this z-score. Your second step is to find this z-score. If this area is 0.995, how much is this shading area? It's really easy, because this shading area is 1 minus 0.995, because the total area under the curve is 1, right? And if you subtract that big area from this, from the 1, it gives you the small area, which is 0.005. Why you need this? Because you are using the table of z-score, correct? But in calculator, it's much easier. What you do, if you use TI-84, open your calculator. Let me turn it on. Again, second variance, go to normal CDF, enter. What is your lower? Your lower is actually sorry. Let me clear this. Okay, now, second variance. Because this area is given, correct? If you are using a table, you have to go and find this number in the body, then read the z-score. But with TI-84, it's also easy. If you come here to inverse norm, which is number 3, correct? And just push the button of enter, and you put your why it's still I'm somewhere else. Let me turn it off and on because my calculator is acting different. Now second variance, and I'm going to inverse normal, correct? Enter. They are asking which area. My area is 0.005. 0.005, correct? Enter. Again enter, and again enter, or move to paste, then enter. This is the value that you enter. One more time enter. It gives you negative 2.575. But because you are here, this number is actually 2.575. Or if you want to get the positive, if you want to get this positive number, use the other area. You see, same thing. Second variance, I'm going down to inverse norm. Instead of 0.005, enter 0.995, correct? 0.995. And actually, this is better to use because we know the z-score is on the right side of the area, correct? Come and paste it. Enter again. 2.575. You see, it's the same thing, but this time is positive, right? This is my z-score actually. My z-score is actually 2.575. We did a step 1 and a step 2. Step 1 we draw, and a step 2 we find our z-score. Now step 3, I'll use my formula, which is x equals sigma times z plus mu. It means x equals, a standard deviation is given as a 29, correct? Times, and also here you have pound, times z, your z score is 2.575, correct? Plus mu, which is 172 pounds. Now step by step, use your calculator and multiply it with 29, these two numbers. This number times 29. Answer 74.699. But what will I do? I also add 172. Enter. 246.69. 246.69, or you can write here 246.69, of course, pound. Correct? 246.69 pound, or 0.7, correct, is the weight that separates the heaviest weight from the lightest weight, correct? You can write that paragraph. Let's do another example. Example number 2. This example is about the grip reach of women, correct? The grip reach for women is normally for women is normally distributed. Is normally distributed. The mean is 27.0 inches. The mean is 27.0 inches, and a standard deviation of 1.3 inches. Find the value value here means your grip reach, correct? That represents the longest that represents the longest 95%, the longest 95% of women. Actually, this example, a car company wants to design a car. They want to make sure that they place, for example, their CD player in a car in a position that a woman can, if a woman drives this car, easily can reach to the CD player without moving from her seat. Her hand can reach. That's why we call it the grip reach, correct? Easily can touch the CD player to avoid accidents, correct? Because when you are driving, you don't want to move yourself, you don't move your eyes, correct? Only the CD player should be in the position that your hand should easily reach to that CD player, correct? This example is about that. Step number 1, you have to draw the picture. Again, draw a standard normal distribution. Of course, the middle line I always draw, but I draw it with dash line. It shows 50-50 two sides, correct? In this problem, this side is the longest. Of course, this side will be the short, correct? Now, 95% of longest. This is 50%. This is 60, 70, 80, 90, 95. I have to draw here my line, correct? This is 0.95. Which side I should reach? I should shade this side, correct? If it's 0.95, of course, the shading area will be 0.05, correct? Another 5%. Now, I want to find my z-score. Again, I will use my calculator. Second, variance. And I'll go to number 3, inverse norm. Enter. I will enter this time 0.05. 0.05. And I'll come down and paste it. Enter. and again enter. Negative 1.645. Negative 1.645. This is actually my z-score. You see, you are on the left side of 0, correct? Your z-score should be negative, correct? Now, last step, I'll use my formula. X equals z times sigma plus mu. It means X equals, your standard deviation was for this problem 1.3 inches, correct? 1.3 inches times your z, which is negative 1.645, plus mu. Your mu is given in this problem as I think 27 inches, right? I told you 27.0 inches. Now again, using calculator, first you can multiply these two numbers, correct? Then add with this. If you do this, you will end up with 24.86 inches. 0.86 inches, correct? It means the longest, how far your CD player should be placed in your car, in your dashboard, 24.86 inches, correct? I'll stop the lecture. This was all about section 6.3. See you all in section 6.4.